so let's go ahead and go over the pedigree worksheet.
Yeah.
Okay, so if we look at the first part, it says consider a pedigree that is tracking an autosomal recessive trait where two recessive alleles are just the little traits that we're looking at, result in the inability to taste a chemical known as PTC. The ability to taste PTC is determined by the presence of a dominant allele. Complete the missing boxes in the chart. The first row has been done for you. Okay, dominant is anytime we're doing and we're fixing to start doing Punnett squares. So when we're talking about alleles, the capital one would be the dominant one. And then the lowercase one would be the recessive. If you have a dominant showing up, you have the trait. Okay. So if this, even though they're carrying the recessive trait, they're still going to show the dominant trait. So number 1, male with genotype big T, little t, would taste the PTC.
I'm going to put yes.
Okay.
What is PTC? I almost said PCP.
We'll have to look it up in a minute. I can't remember the full name of it. Okay, shape in a pedigree. So if you notice in the pedigrees, it'll have 2 shapes, and it'll have a line between them. This would be like a couple that gets married. The circle is the what?
Female.
Yep, so this is a female, and the square is the male. So the son of male, so the shape will be square for number 2. 3, will it be shaded? No.
Yeah.
Now sometimes in a pedigree, if they carry the trait, it can be shaded in halfway. And you'll see that on some of the ones that we're looking at. Okay, number 4. Little t. Can they taste it? No. And it said it's a male, so it's going to be a square. And is it going to be shaded? Yes. So that person on the pedigree would be shaded because they're showing that recessive trait, not just carrying it. And on pedigrees, you have to remember if you're looking at recessive or dominant traits. Some things are dominant, some things are recessive. For this one, we're talking about the recessive trait. So it's colored in if it's showing the recessive trait. All right, number 7, female with a genotype big T. So can they taste it? Yes. And it's a female, so what shape? Circle. Should it be shaded?
Yes.
No, because this is a recessive. Remember, we're looking at recessive. All right, number 10, a female with genotype big T, little t. Can they taste it?
Yes.
Yes, because it's showing that dominant thing. Female, so what shape would it be?
Circle.
And is it shaded?
No.
No, it's a big T, little t. She does carry the recessive trait, but it's not showing, so we're not going to color it in. And then 13, female with genotype little t. Can she taste it?
No.
No. And it's female, so it'll be a circle. And will it be shaded?
Yes.
Yes. Okay, we're going to skip the part of drawing your own pedigree, so skip over 16. 17, what is the phenotype of the sons of generation 3? How do you know? We didn't draw out the thing, but I do want to go over phenotype, what that means. You have 2 terms when you're talking about genetics. You have phenotype and you have genotype. Okay, so genotype is what genes you have. So, if, let's just make up something. If we say that this person had this genotype, so a big T and a little t, that means they have a dominant trait and they have a recessive trait. The only thing that's going to be showing is the dominant. If you ever have a dominant in there, it always shows. Okay? So the phenotype would be what you see. So if this was like for dark hair, okay, they carry a recessive trait like for red hair, okay, but the dominant is their dark hair. So the genotype, they've got dark hair and a recessive trait for red hair. The phenotype would just be what? What do you see with them? What's dominant?
The brown.
Yeah, the dark hair. So I do want you to write what the genotype and phenotype is for number 17. Okay, 18. Circle the genotypes that represent a female with a sex-linked recessive trait. Okay, with sex-linked traits, you're looking at the chromosomes. You're not just looking at the traits. So the female chromosomes are XX. Males are what?
XY.
XY. And then it's going to show the traits that are carried on the chromosomes. So for this one, the XB, big B, little b, means that the person, what? They have the dominant and the recessive. So the genotype that represents a female with a sex-linked recessive trait, she does still have it. She's just not going to show it because she's got a dominant. If you have a dominant, it supersedes the recessive. Okay? So it overpowers it. You don't show it. When we get to talking about Queen Victoria and hemophilia, you're going to see this more and understand it a little bit more. But a woman can pass along this chromosome or this chromosome. So she can pass along the dominant or the recessive. The male can only pass along whatever his X chromosome is. Okay? So guys kind of get the bad end of the deal because if the woman passes along the bad chromosome, they have to show it. If it's a female, like her daughter, if she passes along the bad one, then the daughter gets another good one from the dad and it'll supersede it. Okay, so women don't show stuff like recessive traits as much as men because we have two X chromosomes. All right, so 18 is going to be the X big B little b and then the X little b on both of them. Because both of those are showing the recessive trait because you've got the small letter in there. 19, circle the genotypes that represent a male with sex-linked recessive trait. So there's only two that are males. It's the XYs. The first one is an X big B, so there's that the recessive trait? No, big B is dominant. The next one is X little b, that's the recessive. Okay, so it'll be that one. Okay, 20. View the above sex-linked recessive pedigree. Can you be certain of generation 1, the individual's number 1's genotype? Why or why not? So you've got the pedigree. It shows the woman and the man. And it says the man is X little b y. We don't know what the woman is. But they had kids. How many kids did they have?
Two.
Two. One girl and one boy. And we know the girl is X big B, X little b, and the boy is X little b and the Y. Okay, we know that the boy has it and the dad has it. What do you think the mom's is?
Big B.
Yeah, mom's gonna have to have a big B in there because the daughter's not showing it. So the mom has to have a good one. And she probably has a bad one too. Okay, 21, all males receive their X chromosome from their what? Mom, from their mother. how are sex-linked pedigrees different from autosomal pedigrees? Sex-linked, you have to show the chromosomes in it. So a minute ago when I was doing like the big T, little t, that's just showing the trait. Okay, so if we were looking at like hair color or something like that, these would be the traits. These are actually showing the chromosomes, like the female and male chromosomes and what they're carrying on the chromosomes. All right, so the last one, the autosomal dominant pedigree. We've got the first generation. The female has it, and she's got H, little h. The male has H, little h, or little h, little h. Then they had 2 kids. And then, oh wait, they had, sorry, 1 kid, and this is, and then they had kids. What does the line mean in between people on the pedigree? Yeah, that they're married or that they had kids together. Doesn't necessarily mean they're married, but. Huh? So we've got, and we're looking at dominant traits with this one. So we're looking to see if they have the dominant trait. So this one has the capital H, so she has it. This one has 2 big H's, so he has it. The daughter has a little h, little h. And then we don't really know what these down here have, but can we figure it out?
Mm.
Okay, so we're going to do a Punnett square. This is our first introduction to a Punnett square, and we're going to be doing more of these later on. So the dad had 2 dominants, capital H, capital H. The mom had 2 recessives, little h, little h. So you basically just put in these, what's matching up. So a big H and a little h, a big H and a little h, and it's like that for all of them. So all of these kids are going to be shaded because there's no way that they could be anything else. They're all going to have the dominant trait. They're all going to carry the recessive, but they all have the dominant.